Welcome back to ScaleMeDown and to part 2 of this Tony Ray Kranich glider kit build and review. Remember to like and subscribe to support the channel. And in this episode we're going to tackle the covering and the fitment of the radio gear. So let's get started.
I chose to cover the model in this lightweight heat shrink film that I got from eBay. It's advertised as having a transparent matte finish, but it's actually gloss, and it's just the adhesive on the underside that makes it look slightly matte and opaque. To help it bond better to the surface, I first applied thinned balsa lock. When dry, I then sealed down the covering with the iron set at 100 Celsius. The iron should be set at 110 Celsius for the shrinking, and when heat is applied it goes completely transparent. With the covering done, the horns and hinges could be fitted. This is the wire elevator joiner being fitted. There are both mylar and pin type hinges supplied, although annoyingly 2 less than are required. Thankfully, the scraps box to the rescue. I had to open out some of the laser cut slots for the hinges with a sharp knife. Before covering the wings, I installed the aileron servos with their extended wiring and a little end cap on this tube to prevent the joiner disappearing into the wing. I once again treated the edges with balsa lock that was thinned by 25% with water. I covered each wing using 4 separate pieces of covering. This covering should be more durable than tissue and dope for when it comes to slope soaring. A brand new ultra sharp knife blade was required for neat trimming. Moving back to the fuselage, it's important that we check that the elevator and rudder servos fit the tray before we fit it, as access is really limited afterwards. We now need to fit and shape the nose block, and here I'm making provision for an aerotow release. Unlike the wings, I chose to cover the fuselage with 20 gram per square inch TWILL fiberglass for strength, using EL68 epoxy and slow hardener. I first prepared the surface with 2 thinned coats of sanding sealer, sanding between coats. I then wet out the cloth, trying not to use too much resin. Once cured, I could put on a mask and sand away the excess. The process was repeated until the whole fuselage was covered, and when all was cured, I applied a second thin coat of resin to fill the weave. Now for a splash of colour, and I used plastic primer, adhesion promoter, to help the paint to stick to the shiny covering.
I've spared you the tedium of all the masking, priming, wet sanding and painting. And here we are, she's now starting to look like an elegant vintage glider. And of course it now also means that we're ready for the final assembly process, including the fitment of the tailplane and rudder, the canopies and all the control runs and such.
Let's start by fitting the tail surfaces. The tailplane was meant to screw on with supplied self-tapping screws, but I used epoxy. It's very important to check for proper alignment with the wings, tailplane and vertical fin. Next were the landing skids, after marking where they fit with masking tape. The radio gear needs to be quite small, and thankfully Steve Webb models can point you in exactly the right direction here. I'm going to use this FrSky GR-X8 receiver with built-in variometer. We'll power it from this 2-cell LiPo, which is the biggest I could get to fit in the nose, through this 5-volt UBEC. The instructions suggest a cable and torsion spring arrangement for the elevator, but there's no details supplied, so instead I opted for a carbon fibre pushrod, while sticking with the supplied pull-pull cables for the rudder, using EZ connections at the servo horn. The aileron connections are conventional and all the hardware is supplied in the kit. A quick look with all the surfaces connected up. Before we tidy up the installation, it's worth noting that there's no control throws mentioned anywhere in the instructions or on the plans. Next to the toe release, and here a multiplex release is just too big, so I came up with my own thing. The green item is a plastic tube that's fitted into the nose and has a slot cut into it. The red part is a toe adapter, which is a rod with a groove in it, and it's tied to the end of the toe line. The servo horn shown in purple here locates into the slot in the toe adapter, locking it until glider release. And here it is in practice. There's not much space for the radio gear. However, there is space for a couple of pilots from our resin 3D printer. It was then a simple job to trim and fit the canopies. I used canopy glue for this, and also to fit some strips of pre-painted paper for the framing.
She's all finished, and I've got to say this is a lovely kit and an enjoyable build. The finished airframe came out at 266 grams, and then I needed to add 84 grams of nose weight, with a further 50 grams of weight added with the flight battery, bringing the all-up weight ready for flight at 400 grams. The toe release was entirely my addition and is nothing to do with the design. However, it's just that we fly gliders from a flat field from an aerotow most often. The installation of the radio gear was fiddly due to the restricted space, particularly inside the fuselage, so you really need to take your time. And a few more photographs and details will be appreciated here in both the plans and the instructions. The centre of gravity is accurately stated on the plans, but the control throws are not, and that's really not acceptable. However, we'll fix that and report back when she's flown. Meanwhile, if you missed the build video, I'll put a link here for you to enjoy. And join us next time where we'll conduct the maiden flight with this model glider. Thanks for watching, and we'll see you next time.